Hello and welcome to Precalculus lesson number 1. In this lesson, we're going to review linear equations. Any equation that can be put into the form ax plus b equals 0 is called a linear equation in one variable. Here, x is the variable and a and b are constants. And linear equation is also called a first degree equation given that the greatest degree of the variable, which in this case is x, is 1. So you won't see any x squares or anything like that if x is the variable in a linear equation. To be able to efficiently solve linear equations, we need to understand the following properties of equality. We have the addition subtraction properties of equality, which basically say if you have an equation a equals b, then you can basically add the same constant to both sides. And it also works with subtraction, so you can also subtract the same constant from both sides, and you don't change the validity of the original equation. And this is true for all a, b, c belonging to the set of real numbers. The multiplication division properties of equality are basically the same properties, but with respect to multiplication and division. So given an equation a equals b, you can multiply both sides by the same constant, and you can divide both sides by the same constant. Of course, in the case of division, we need to add the extra requirement that the number you're dividing by should not be 0, because as we know, division by 0 is undefined. All right, let's say we want to solve this linear equation. The basic strategy is going to be very simple. We're going to go through 3 steps. We're going to simplify, then we're going to separate, and finally solve. So what we mean by simplify, as you can see, each equation is going to have 2 sides. So there's an equal sign and an expression on either side of it, right? So we're going to simplify each side of the equation. Then we're going to separate the variables from the constants, and then we're going to proceed to solve. So let's go ahead and do that. So here we're going to go ahead and distribute the 7. So we get 21x plus 42 equals 11. Now be careful, here we have the invisible -1 that we're going to distribute. So we get minus x and then minus 2. So here we're still in the simplify stage, because here we have some terms we can combine, the 11 and the -2. So we end up with 21x plus 42 equals 11 minus 2 gives us 9 minus x. Okay, so now that we have fully simplified both sides, we're going to go ahead and go on to the separation phase. Here you have to decide which side you want to move the variables to and which side you want to move the constants to. It makes no difference, but normally we like to go to the side where the larger coefficient of the variable exists, because that way we're going to end up with a positive coefficient in the next stage, so that we don't have to end up dividing by negative, given that usually more errors happen in that case. So here, since the 21 is the larger coefficient, we're going to go ahead and move the -x to the other side by simply just adding x to both sides. Now we're using the addition property of equality, and since we want to move the 42 to the other side, we're going to subtract 42 from both sides. We could do that in a new step, but why not take care of it right here, right? So we'll just go ahead and subtract 42 from both sides as well. So now we end up with 22x equals 9 minus 42, which is going to give us -33. So now we're going to apply the division property of equality by dividing both sides by 22 so that we can isolate the x, and we'll be almost done at that stage. So we go ahead and divide both sides by 22. So we end up with x equals negative 33 over 22. As you know, in a math class, we usually like to simplify fractions as much as possible if doing so is possible. And in this case, we notice that 11 goes into both the numerator and the denominator. So if I cross cancel, I'll end up with 3 on the top and 2 on the bottom. We're just dividing both 33 and 22 by 11, and we end up with negative 3/2. So we are going to write our solution set in this manner. So we say the solution set equals, we'll use braces, and we put only the solution within the set like that. So our solution set contains only one element, and that's negative 3/2. We don't put the variable in there, only the value of the solutions. Now, you can always check the solution of a linear equation by plugging in the result that you obtained into the original equation. So if you want to check it, you just go 7 times. Now here I'm plugging in negative 3/2 like so, right? Plus 6, and we end up with, on the other side, 11 minus quantity negative 3/2 plus 2. Okay, so let's go ahead and simplify a bit. So 7 times negative 9/2 plus, let me just use one set of parentheses here, plus 6 equals 11. Now this negative gets distributed, so we get plus 3/2 and then minus 2, because negative times positive will give us a negative here. So we have negative 63 over 2. Here we're distributing the 7 plus 42, and we need to put question marks on top of those equal signs because we're checking. We haven't established that the two sides are equal yet. Equals, that's going to be 9 plus 3/2, right? Now I could quickly multiply both sides by 2 to get rid of all the fractions, because that'll make life a lot easier. So we'll do that, and remember, we're going to distribute the 2, so the 2 is going to get multiplied by every term. So we end up with these canceling out, so we get negative 63 plus 42 times 2 is 84. We want to know if that's equal. We continue with the question marks because we haven't established yet. 18, and here the 2's cancel out, we get plus 3. Now on the left side here, I have negative 63 plus 84, which is 21, equals, and on the other side I also have 21 because 18 plus 3 is 21. So now I don't need the question mark anymore because I have verified that substituting negative 3/2 for x in the original equation makes the equation true. Therefore, that's what is meant by a solution, and we have found the correct solution. So that's how you can solve and check a linear equation. Okay, here we have another equation. This one has fractions from the get-go. So what we would like to do is we would like to use the multiplication property of equality to eliminate those fractions and just work with whole numbers, which is a great tool to have available to us because it's much easier to work with whole numbers or integers, right? So we notice that the least common multiple of the fractions on denominators of the fractions on both sides is 10. So if we simply multiply both sides by 10, we should be able to clear those fractions. So we go ahead and do that. Now notice this is just one term, right? So we don't need to distribute at this time because we're just going to multiply by the one term that we have on each side. So on the left side, the 5 and 10 will leave us 2. On the right side, the two 10s cancel out. So now the simplified equation is going to be 2 times 7t minus 4 equals t plus 4. So you see that's much nicer and simpler to work with because we don't have any fractions anymore. So now we go ahead and distribute the 2. So we get 14t minus 8 equals t plus 4. Let's go ahead and get the t's on the left side. That's where the larger coefficient for t is. So we're going to go ahead and subtract t from both sides, and we'll move the negative 8 to the other side by simply adding 8 to both sides. So now we end up with 14t minus t, which is 13t. These of course cancel out, equals, and these two cancel out here, so we get 12. And we end up with t equals 12 over 13. Here we just divided both sides by 13. All right, so as you know, we write the solution set as the set containing just 12 over 13. Okay, now it's always a good idea to check for the purpose of keeping this video at a reasonable length. I'll go ahead and show you how you can check that on a calculator, but it's always better to do it by hand so you can get some extra practice anyway. So here we'll go ahead and let me make this a little bit smaller. All right, so now here's what we'll do. We'll go ahead and just type the fraction at the left side as we see it. So we have 1/5, and we're going to need to hit the right arrow on this fraction to get out of that denominator. So we go ahead and multiply by 7 times. I'm going to go ahead and open another parenthesis because I'm going to type in the 13 over 12. Oh, 12 over 13. All right, so now we're going to get out of that denominator, and we're going to get out of the first, that set of parentheses, and we're going to type minus 4, okay? And once we hit enter, we get this number on the left side that we see displayed on the screen. So now we'll do the same thing with the right side. Remember the original equation. So 1 over 10, and we go ahead and, oops, we need to get out of the parentheses first. So we'll hit the right arrow to get out of the denominator. And now we'll put parentheses. So now we want 12 over 13. Hit the right arrow and then plus 4. Now, as soon as I hit enter, what am I hoping to see? That number, right? And we do. Okay, so we just verified that substituting 12 over 13 into the original equation without any cancellations or anything will indeed make the equation true, because I get the same number on the left side that I would on the right side. And there we have checked it using a little bit of technology. All right, that's how we do that. All right, so here we have another equation we're going to solve. This time we're dealing with decimals, right? And what we're going to do is we're going to do a similar thing to what we did with fractions by clearing the decimals first. So what we do here is we notice how many digits we have after the decimal place here. We have 2 here and also 2 here, and we don't have any decimals on that side. So all we need to do is multiply by 100. So a 1 and as many zeros as you have digits after the decimal, and we look for the one that requires the largest number of digits. In this case, they only both require 2 zeros, so that's why we'll multiply by 100 on both sides. So, and don't forget, we're going to distribute that 100 as well, because we're multiplying it by an expression which is a sum. So we get 100 times 0.13y plus 100 times 0.08 times y plus 6,000. Now remember, this whole thing is one term, right? So you don't multiply the 100 by the 0.08 and also by the y plus 6,000, because once you've multiplied it by the 0.08, you're done for this term. So, and on the other side, we get 100 times 1,530. So on the left side, we have 100 times 0.13, which just gives us 13y, plus 100 times 0.08, which gives us 8, times y, quantity y plus 6,000, equals, and on the other side, we have 153. There is a 0 already. We add 2 more zeros for the 100. So like that, okay? 153,000. So we keep going, 13y. Remember, we're doing the same 3 steps. Simplify, separate, solve, right? So plus 8y plus 8 times 6,000 is, of course, 48,000 equals 153,000. So now we'll continue with our simplifying phase, and we're going to combine the 13.8 and the 13y and the 8y, so we get 21y plus 48,000 equals 153,000, okay? As we go through the term together, it's always a great idea at the beginning of every problem to pause the video, try to solve it on your own, and then come and see if you have the same answer as I do. Of course, that's when you feel like you think you should be able to do it. So that way you're engaged in the learning process and you're handling this in an interactive way. Otherwise, watching a math video like as if you're watching a movie, well, it would certainly be a very boring movie, right? But it would not really be that helpful, okay? So you want to be actively engaged. All right. So now we're going to go ahead and keep the y on this side, the variable term, and we'll go ahead and move the 48,000 to the other side, which we can of course do by just subtracting 48,000 from both sides. All right, so now we end up with 21y, these cancel out, equals, now we have 153,000 minus 48,000, so we have, let's quickly do that here, 153,000 minus 48,000, so we get 105,000. So now we'll go ahead and divide both sides by 21, and we end up with y equals 105,000 divided by 21. So here we have that already on the screen, so we just go ahead and hit divide by 21, and we end up with 5,000. So we get y equals 5,000. All right, I showed you how you can check using technology, so I'll leave that to you. And once you have checked and verified, then you write your solution set as the set containing just 5,000, like that, okay? And that's how that's done. If you start doing a problem on your own and you don't get the right answer, then you watch how I do it and you learn it, then you definitely pause the video, redo it from scratch without getting any help or looking at the answer in any way. Just on a blank piece of paper. That's how you make sure that you have it before you proceed. All right, next we want to talk about the types of linear equations in one variable. They basically fall into three categories. One, we have the conditionals, which basically have only one solution. Then we have the identities, which have infinitely many solutions. And we have contradictions, which have no solutions. Remember, just because somebody gives you an equation like this, it doesn't mean you're always going to be able to find the solution. We'll find out in a second why. So let's start with the conditionals. These are the ones similar to every single one we've done so far, right? We've always just come up with one solution, right? Notice if I just take this x plus 2 equals 5 and subtract 2 from both sides, I obviously just get x equals 3. So this equation is true if x equals 3 and false if x is any other number. So we just say if x does not equal 3, okay? Now, this next one over here, let's see why this we call an identity and why we say it has infinitely many solutions. Well, just looking at it, it's obvious that I can plug in any number and this will be true, right? Plug in 2, you get 2 plus 2 equals 2 plus 2. Of course, 4 equals 4. Plug in a half, you get 2.5 equals 2.5. So you can do that even with negative numbers. Any real number should work. Now, what happens if you actually try to solve an equation like this? Well, let's see. Let's move the x's to the left side. So I'm just going to subtract x from both sides. And let's move the 2's to the right side. Doesn't make any difference which side you really move them to, right? Because you're going to end up with 0 equals 0. When this happens, well, this is obviously a true statement, right? 0 is equal to 0. So when you try to solve an equation and you end up with an identity, any number equals itself, that kind of an equation is called an identity, right? That means this equation was always going to be true no matter what real number you plugged in. So here we notice that the solution set is going to be all real numbers. And of course, how many real numbers are there? Infinitely many, right? So that's why we say these have infinitely many solutions. Now, how about this last one? Now, obviously, first of all, notice that identities or contradictions never look this obvious usually, right? Well, I shouldn't say never, but usually do not look this obvious. Sometimes you have to go through several steps of simplifying before you realize you were dealing with an identity or contradiction. I just gave these real simple examples to get the point across. Look at what we're asking here. We're asking you to find the number that basically stays the same if you add 2 to it. Well, that's impossible, right? Because you take any number and add 2 to it, what's going to happen? You're going to get a different number, right? A larger number. So what happens if we try to solve this? Well, let's go ahead and subtract x from both sides. Let's see what happens. Well, notice we end up with 0 equals 2. This obviously is a contradiction, right? So if trying to solve a linear equation, you end up with a contradiction, that means the original equation itself was also an impossible equation to solve, and we call those kinds of equations contradictions. Notice that the solution set here would be empty. Now, if somebody asks you what is the number of solutions of these equations, obviously you would say what? 0. Remember, you're not saying 0 is a solution. You're just saying there are 0 many solutions. In other words, there is no solution, right, to this equation. All right, so these are the three different types of linear equations in one variable that we may encounter. All right, here's an equation. I want you to try it. So pause the video, simplify, try to solve it as if it's any other equation, and see if you can determine whether it's a conditional, an identity, or a contradiction. When you're finished, come back. All right, welcome back. So we just distribute the 6, right? So we get 6x minus 6 equals, on the right side, we're going to distribute the -3. And remember, the distribution ends where this parenthesis closes, right? So you only distribute the -3 by these two terms. So we get -6 plus 3x, and then we already have a plus 3x, so don't forget that. So notice we get 6x minus 6 equals 6x minus 6. You can already see we're looking at a what? Identity, right? So, but just to satisfy ourselves, we could always take it to its logical extreme, subtract 6x from both sides, and add 6 to both sides as well. And once again, we end up with zero equals 0, right? So this is when we realize, oh, we were dealing with an identity, so we know that the solution set is the set of real numbers. That means you can say also, you can put this in set builder notation, you can say all x such that x belongs to R. And how many solutions do we have here? Obviously, we have infinitely many solutions. Okay, so that's how you take care of that. All right, go ahead and try this one and see what you end up with. Conditional, an identity, or a contradiction. By the way, real quickly, the last one which we did, we need to identify as an identity, right? All right, so let's go ahead and move on to the next one and try it, okay? Okay, so I'm sure you went ahead and distributed the 8, so we get 8v plus 24 minus 2v equals, now we're going to distribute the 2, so we get 6v plus 8, and then don't forget we have the minus 9. So on the left side we have 6v plus 24 equals 6v minus 1. Of course, here these two items are identical, these two parts, and yet these are different. So this can't be true, right? This can't be possible to solve. Let's go ahead and just go one more step. If we subtract 6v from both sides, and let's say, for example, we add 24, subtract 24 from both sides, notice what we end up with. We end up with 0 equals negative 25, which is of course a contradiction. So that means the original equation is also a contradiction. And the solution set is empty, and the number of solutions here is 0. Remember, not the solution, but the number of solutions. Okay? So there you go. Okay, in this next example, we're going to solve this formula for S. And in order to do that, the first thing we're going to do is go ahead and eliminate the 4 since we can multiply both sides by 4. So let's start with that. So we end up with 4a equals 4 times 1/4 f times s plus k. So on the right side, we notice that the 4's will cancel. So now we have 4a equals f times s plus k. So we have to keep in mind what we're solving for, which is s. So we need to get that s somehow released from this group here. So there are a couple of approaches. I'll show you both. The first approach is to go ahead and distribute the f. So we end up with 4a equals fs plus fk. And since we're solving for s and there's only one s term, we go ahead and isolate that by subtracting fk from both sides. So now we have 4a minus fk equals, and of course these two will cancel out, so we just get fs on the right side. Now we're almost there. We want to solve for s, so we just need to divide off the f. So we'll go ahead and divide both sides by f. Now on the right side the f's cancel out, so we end up with s on the right side is equal to 4a minus fk over f. Okay, so there is one approach that will get us a solution. It's very important when you solve formulas like this that when you're solving for a given variable, you make sure that that variable does not appear anywhere in the so-called expression that you have found for it. So we notice there are no s's here on this side, so we should be good to go. Now the other thing we could have done is, let me go back to this step. That's where I said there are a couple of approaches. So let's go ahead and try this. Start with 4a equals f times s plus k. What we could have done is we could have divided both sides by f right away. So it would have worked out like this. So our next step would give us 4a over f equals, on the right side, of course, those f's will now cancel out and we just get s plus k, right? So now all I need to do is subtract k from both sides to get s by itself, right? So on the right side, we now just have s because the k and minus k cancel out. And on the other side, we have 4a over f minus k. So you may take a look and say, whoa, those look different, right? Well, they better be the same if we've done it correctly, right? So let's see if we can make this expression here, 4a over f minus k, look like this one. So let me start with 4a over f minus k. I'm going to go ahead and write it as k over 1 because I want to combine these two fractions. So my common denominator is f, which means I need to multiply the top and bottom of the second fraction by f. So now we have 4a over f minus kf over f. But I now can put them just under one fraction, given that the denominators are the same, under one denominator, and I get 4a minus kf on the top. So notice they do end up being the same if you just convert one form to the other. And kf, of course, is the same as fk by the commutative property of multiplication. All right, so there are a couple of different ways to attack this problem. Make sure you can handle it on your own before we proceed. All right, so here we have another equation. Notice that even though there's a v squared here, this is still considered a linear equation in k, because the k is the variable we're trying to solve for, and we can treat this as a linear equation as far as the variable k is concerned, because the only power of k that we see is the first power. So it is a first degree equation in k. If we were solving for v, for instance, then it would be a quadratic equation in v, but we're not. We're solving for k. So make sure you try it first on your own before you watch the rest of the video. All right, so since we want to solve for k, we're obviously going to isolate the k term whenever possible. And it is pretty easy to do that by just moving this term to the other side. So we're going to go ahead and subtract 3 pi v squared from both sides. We can do that by the subtraction property of equality, of course. So we end up with s minus 3 pi v squared is equal to, of course, these cancel out on this side, and we end up with 3 pi v k. All right, so since we're solving for k, all that's left to do is to go ahead and divide both sides by 3 pi v, and we should be good to go. So let's go ahead and do that. So we end up with only k on the right side because everything else cancels out. The 3's cancel out, pi's cancel out, v's cancel out. And on the left side, we have s minus 3 pi v squared over 3 pi v. All right, so what you want to make sure with situations like this is to not have k anywhere in the solution for k, obviously, right? This is a common error when there's more than one k term. For example, students end up having k in the answer as well, which would not be correct. As long as there are no k's here and there's only a k on the other side, we should be in good shape. Generally, these kinds of equations which have a more than one variable in them are referred to as formulas. They usually come either from chemistry or physics, etc. That's where you will encounter these, sometimes in finance, etc. So that's how you would handle a problem like that. Okay, in this example, we want to solve this equation for x. And since we have a fractional situation, we'll go ahead and clear the fraction by multiplying both sides by c minus 3. So we get quantity c minus 3 times x over c minus 3 equals quantity c minus 3 times quantity cx plus 6. Now we notice that on the left hand side, the c minus 3's will cancel out. So now we have x equals quantity c minus 3 times quantity 6x plus, okay, cx plus 6, right? So notice that instead of saying open parentheses, c minus 3, close parentheses, etc., I use the word quantity. So when I say quantity c minus 3, that means open parentheses, write c minus 3, and at the moment I say times, that means close the parentheses, and then I say quantity, that means open another parentheses, and then cx plus 6, and I stop. So that means go ahead and close the parentheses. This way you don't have to keep saying open, close, etc. So now we have x equals, we're going to go ahead and distribute the c, and then we'll distribute the negative 3. So I get c squared x plus 6c. Now we're distributing the negative 3, so we get minus 3cx, and then minus 18. Okay, so now we're solving for x, right? So we want to get all the x's on one side. So since I already have two x terms on this side, let's go ahead and move the x, all the x's to this side. So that means we're going to go ahead and subtract x from both sides. Doesn't matter where I really put it. I'll just put it under this one since it's a first degree term. And don't forget that the 6c and the negative 18, we're going to want to move to the other side, right? So we're going to go ahead and take care of it all at the same time. We'll subtract 6c from both sides. And we'll also add 18 to both sides, right? Okay, so now we carefully see what we have on each side. On the left side, the x's will cancel, so we get 18 minus 6c. On the right side, those cancel out, and so do those, right? So we have c squared x minus 3cx minus x. Right? All right, now here's where you want to be careful. We're solving for x, so that means we're going to want to isolate x. So of course we can do that easily by factoring out the x. We notice that x is a common term in all three of those terms, so a common factor, I mean. So we go ahead and factor it out, so we get c squared minus 3c minus 1. Make sure you don't forget the minus 1, because when you multiply the x back in, you should get this, right? And we do right now. C squared x minus 3cx. If we didn't have the minus 1, we wouldn't get the minus x, right? So be careful. So now we're almost there. We just need to divide both sides by c squared minus 3c minus 1. And we're good to go. So on the right side, of course, those will cancel out, and we end up with x on the right side equals 18 minus 6c over c squared minus 3c minus 1. All right, if the problem, for example, wants you to put all polynomials involved in descending order, you could also write it as x equals negative 6c plus 18 over c squared minus 3c minus 1. They're both correct. You know, we usually prefer this because it's nice, the leading term is positive, etc. All right, so that's how you would approach that. So if you didn't get that answer initially by trying it on your own, make sure you run through it again till you get the correct answer. All right, let's take a look at this word problem now. Rick borrowed $100 from his brother Jack to pay for books and tuition. He agreed to pay Jack in 6 months with simple annual interest rate at 6.8%. We want to know how much will the interest amount to, and what amount must Rick pay Jack at the end of the 6 months. So in order to be able to do this, we need to know the formula for simple interest, which is I equals PRT. Here the P stands for principal, which is simply the amount of the loan. The rate is the annual interest rate, right? So and the time, the T is time in years. All right, so in our situation, P is going to be $100. The rate is 6.8%. If I write it as 6.8 over 100, I can quickly turn it into a decimal by moving the decimal 2 to the left, so I get 0.068. The time is 6 months, right? But I need to convert that to years, so I'm going to multiply by a unit factor. I know that 12 months corresponds to 1 year, right? So I multiply by that unit factor, and I notice that 6 and 12 will leave me 2. So that's basically 1/2 of a year, right? Because in this formula, we need to plug in the time in years, not in months or any other unit. So we end up with I equals 100 times 0.068 times a half, which is the same as 0.5, right? All right, so we end up with, let's go ahead and plug all that into a calculator. So 100 times 0.068 times 0.5, so we get 3.4. So basically the interest that Rick is going to have to pay is $3.4, right? So what's the total amount? Well, the total amount that he's going to have to pay is the original amount, right? The principal plus the interest. So it's going to be 100 plus 3.4. So we get 103.4. So to answer properly, how much will the interest amount to? We'll say $3.4. And how much will Rick pay Jack at the end of the 6 months? Again, we'll use the proper units, dollars, so 103.40. Now usually we like to put that zero even though it doesn't count, because we're dealing with money, so it's clear. All right, so that's how you would handle a problem like that. All right, let's go ahead and finish this lecture with this interesting problem. All right, we know that this equation here, F equals 9/5 C plus 32, basically gives the Fahrenheit temperature equivalent of a given Celsius temperature measurement. So the question is, at what temperature will the Fahrenheit and Celsius scales have the same value? There is, in fact, such a temperature. So here's what we'll do. What we're going to see is where 9/5 C plus 32 ends up being equal to the Celsius measure, which is C. So we're going to replace F with C. So we get C equals 9/5 C plus 32. And this is the temperature at which the Fahrenheit scale will give the same result as the Celsius scale. So now we go ahead and multiply both sides by 5. Again, try to solve this on your own. So we get 5 on times C equals 5 times that expression. 9/5 C plus 32. So we end up with 5C equals, notice the 5 times 9/5 C plus 5 times 32. The 5's cancel out on that expression, so we end up with 5C equals 9C plus 5 times 30 is 150, 5 times 2 is 10, so 160. So now we're solving for C. Let's go ahead and move the C's to the right side where the higher coefficient is. And we're going to go ahead and move the 160 to the left side. So we get minus 160 minus 160. So we end up with negative 160 is equal to 4C. All right, so now we divide both sides by 4. And we end up with C is equal to negative 40. All right, so the magic temperature at which the Fahrenheit and Celsius measures give the same have the same numerical value is negative 40 degrees. Try it. Go to Google and say convert negative 40 degrees Celsius to Fahrenheit and see what happens, okay? All right, so that does it for our first lecture. You take care, and we'll see you at the next lecture.